Hi everyone, this is a lecture on significant figures, otherwise known as Sig Figs, or I like to abbreviate them as SFs. So, what are significant figures? Why are they important? Well, significant figures are basically all the possible digits in a measurement plus one guess. And instead of guess, maybe a better word might be an estimated place. So significant figures are used in measurements. In chemistry, every number we use will be a measurement, whether it comes from a ruler, a meter stick, a beaker, graduated cylinder. Every number is a measurement. And so significant figures are, in that measurement, all of those digits that you read on the scale and the one extra estimated place you get. So what's the purpose of Sig Figs? Well, every piece of equipment has a scale on it. Sometimes that scale is really good, sometimes it's not good. The purpose of Sig Figs is to accurately read the numbers on those scales. So Sig Figs allow us to show how precise that instrument we're using, that tool we're using is, how precise our measurement is when we use that. Okay, it allows us to say, this is a ruler and I can accurately read it to this place, meaning this is a ruler and I can accurately see on the scale, I can read all these numbers that I'm certain about, and here's my one extra guess or estimated place. That's significant figures. So let's take a look at this example here. You have a pencil laying on top of a ruler, and yeah, the picture is blurry, so don't think it's something wrong with your iPad. No need to adjust. So the first thing you want to do when you see a scale is to figure out its increments. The increments are the tick marks you see on the scale on the ruler, also called gradations. And if you look at this, you could see a 7 and an 8, and in between tick marks. And if you notice, there's a tick mark for every single tenths place. So I see 7.1, 7.2, 0.3, 0.4, 0.5, 7.6, 7.7, 7.8, 7.9, 8. Do you see that? So this scale goes up by 0.1, goes up in the tenths place. So that's the first step you want to do. Next, you then want to try to see where the edge of what you're measuring, where it falls on the scale. And you want to look very closely and be as precise as you can. So I would probably say, whether you're reading this or your partner's reading this, that for sure this pencil is 8.2 something. Okay, so I for sure see the 8 on the scale. For sure I see the 0.2 on the scale. There's a tick mark there. Now, remember, in a measurement, you get all the numbers you're certain about. 8.2, I'm certain, I see it on the scale. Plus, you must make one estimation, one guess. So if you notice, I kind of drew in an arrow because I was going to take my estimation right around there. And so your estimation can be however you perceive this measurement. So I guessed 8.25 inches. That is my estimation. Remember, that estimation and those certain numbers is your measurement. And they are the numbers in your measurement that are significant. Okay, so what about if I don't have a measuring instrument in front of me? What if I'm not in lab and instead I see a number on my paper in chemistry? How can I tell which of those digits are significant and which aren't? Well, there are rules for that. So let's take a look at those rules. There's about 4 rules. So rule number 1, when you're looking at a measurement that's on a piece of paper, all the non-zero digits are significant. So if the measurement has a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9, any of those non-zero numbers, they're significant digits. All right, that's easy enough. Let's look at rule number 2. Rule number 2 addresses zeros. All zeros that are between significant figures are significant. These are called trapped zeros or captive zeros. So if you look at my examples, I highlighted them in red, and you have a measurement of 305. I don't know, let's say you have 305 meters. The 3 and the 5 are obviously significant, right? Rule number 1 said all the non-zero numbers are significant. Well, that 0 is trapped. It's trapped between two significant figures. If the 0 is trapped, it has to be significant. So in the number 305, there are 3 significant figures. 3 significant figures. I'm going to write that over here on the side. Okay. The next example, again, 0's trapped between significant figures. 1 and 5 are always significant. And so the 0's fall in between. So there are 4 significant figures. Let's look at the next one. Again, trapped 0's in the red. To trap between 6 and 5. Therefore, everything in this is significant for 4 sig figs. The next rule also talks about 0's, and they're called leading 0's. So if you notice, I highlighted them in red again. Leading 0's are 0's that come in the front, right? They're the leaders. They're the first ones seen in the beginning of the number. These are not significant. So if you notice, they're there, but they're not where the measurement was being taken place. Now, don't get confused. Just because they're not significant doesn't mean they have a purpose. These 0's definitely have a purpose, though they are not significant. Well, what's their purpose? That's right, you guessed correctly. They're placeholders. So without them, these numbers would be very different. Like, for example, take a look at 0.0025. If I got rid of the placeholding 0's, I would have 25. Well, is 25 a different number than 0.0025? Definitely. So we need those placeholder 0's. But are they significant? Was a measurement taken place in those 0's? No. The next rule, again, also has to deal with 0's. This is a little bit of a hefty rule. So let's take a look at this. It says trailing 0's are not significant. Trailing 0's. Those are 0's that come at the end. Like when you trail, when you're left behind, you're at the end. So trailing 0's are not significant. So 0's at the end are not significant unless there is a decimal present anywhere in the number. Okay, so let's look at our examples. The first set, kind of seen here in red, says all of these numbers have a decimal. So if you notice, look, 100.0, 10000 decimal, 0.10, 0.100. All of these numbers seen here in this first segment in red have decimals. If there is a decimal present anywhere in the number, the 0's are significant. So in this first one, all of these 0's are significant, plus obviously the 1. So there are 4 sig figs. In this one, seen here, second example, all of the 0's are significant, right? Here's that decimal. So there are 1, 2, 3, 4, 5 sig figs. Count with me. Make sure you understand. In this next example, there's a decimal. It's in the beginning of the number, but it doesn't matter. As long as there's a decimal somewhere, it makes that trailing 0 significant. So there are 2 sig figs. And in this one, 3 sig figs. So trailing 0's are significant if there's a decimal somewhere in the number. Now, how about if there's not a decimal present? Well, that's the second set seen here after the blue part. It says all of these numbers do not have a decimal. And so the 0's are not significant. You see that 100? No decimal. 0's are not significant. So there's 1 sig fig in that number. So again, don't get confused. Just because those 0's are not significant doesn't mean they don't have a purpose. They definitely do. What's the purpose? That's right, placeholders. Because saying that you have 100 of something versus 1, that's a big difference. So in the next example, the one that says 10, there's only 1 sig fig there because that 0 is not significant. And in the last example, the 1,000, there's only 1 sig fig there too. No decimal present, trailing 0's are not significant. All right, now that we have Finished our rules. Let's practice. I'm going to zoom in here. Don't look at the answers. Okay. How many sig figs are there in 100? If you guessed 1, you are correct. Next one. How many zeros are on 90 with a decimal point? If you guessed 2, you are right. Remember, that decimal point anywhere in a number makes a trailing zero significant. And let's look at this one here. Excuse me. How many significant figures are in this measurement? Now, don't get confused. There is a decimal, but are those trailing zeros? No. Those are leading zeros. Are leading zeros ever significant? You should have said no. Remember, feel free to pause this and go back to the rules, or hopefully you're taking notes like you're supposed to and you could see your notes. Leading zeros are never significant. They are just placeholders. So in this example, there are 3 sig figs. Good. How about this one? Okay, don't get confused. A combination here. We've got a leading zero and we have trailing. Is that leading zero significant? That's right, it is never significant. How about those trailing zeros? Correct. There's a decimal present anywhere in the number, then the trailing zeros are significant. So you should have answered 3 sig figs. How did you do? That's the end of the lesson. Please feel free to go back and revisit any of the rules or any of the measurement stuff. You can watch this as many times as you like.